Hi, geometry classes. This is circles, lessons 2 and 3. So we're going to talk about central angles and inscribed angles today. So a central angle is an angle with its vertex at the center. All right, center here. At the center of a circle, and its two sides are actually radii of the circle. So radii is just plural for radius. The sum of all central angles in a circle is 360 degrees. Okay, so the example that I have right here to the left, I have angle ABC. That is a central angle. Notice that B is in the center of the circle, all right, and AB and BC are both radiuses of the circle. The degree of the arc formed by the endpoints of the central angle is congruent to the degree of the central angle. So the measure of arc AC, I'm just going to highlight that for us. So arc AC is this part right here. So an arc, remember, is just part of a circle. The circumference is the distance around the whole circle, and arc is just part of it. So arc AC, which is formed by the endpoints of angle ABC, is equal to angle ABC. So it's actually equal to 84 degrees. So the central angle and the arc are congruent to each other. The measure of arc ADC, so remember that's a major arc. I'm using 3 letters, so that's talking about this arc right here that I'm drawing in green. That would be equal to 360 minus 84, because remember a full circle is 360 degrees. Okay, let's try some examples together. So our first one, I want to find the measure of arc JK, so I'll highlight that in yellow. So arc JK is talking about this right here. Well, we just learned that the arc is equal to the central angle. If that central angle is 21, then arc JK is 21. Next one I want to find is angle JNM. So JNM is right here. Okay. Now look at my circle. MK is a diameter. So that makes that line right there, don't even worry about the fact that it's a diameter, but MNK is a line. If the angle on the right is 21 degrees, then the angle on the left has to be 180 minus 159, 180 minus 21, I was saying the answer, which is 159. Okay, so this is 159 degrees. Then I want to know arc KL. So arc KL is talking about this arc right here. Arc KL in blue. All right. Well, remember, if the angle JNM, which I just found is 159, so is this angle on this side, because those are vertical angles. So that makes this arc 159 as well. And arc JKM. All right, JKM. I'm going to run out of colors here. JKM is starting at J, going to K, and then all the way around to M. So it's this whole thing. So basically, let me just write this in. They didn't ask me for arc JM, but arc JM is also 159. And that part of the circle is everything but the 159. So if you just did 360 minus 159, that would be the arc, and it would be 201. Okay, and arc MKL. So MKL, I'm going to have to erase some of this, what I had here, just so we can see. MKL, so MKL is everything but that tiny little piece. And remember, if this angle's 21, this angle's 21, which makes this arc 21. So it's 360 minus 21, which is 339. Okay, so just knowing that one rule, there's a lot of problems that we can actually do. You have to look for vertical angles. You're going to look for things like lines, because remember, lines equal 180 degrees. All right, let's do an algebra one, like number 3. So this is a line. That's a diameter. This, which I'm highlighting in yellow, is half a circle. Remember, a whole circle is 360 degrees, so half a circle would be 180 degrees. Okay, so if I add those two arcs together, and I'm going to set them equal to 180 degrees. So combine the x's, the 5x and the 17x, that's 22x. Combine the 23 and the negative 41, that's negative 18. I'm going to add 18 to both sides. Okay, and then I'm going to divide by 22. And I get x equals 9. So that's that first thing. And then they just want me to substitute in. The first thing I want to find is I want to find arc JK. So that's going to be 5 times 9 plus 23. So that equals 68. Arc MJ. Well, arc MJ is actually equal to arc LK. All right, so I can just plug that in. Or it's half a circle, so all I have to do is 180 minus the 68, which is 112. And arc LMK, let me get a different color here. LMK. LMK is all of this that I just highlighted in blue. All right, well, I know this piece right there, which I just found out, is 112, so it's 360 minus 112. Another way to do this would just be to add up all the pieces that I had. Like I found out that this was 68, that makes this 68 because those are vertical angles right here, and this was 112, so you can add up those. The second kind of angle I want to talk about today are inscribed angles. So an inscribed angle is an angle with its vertex on the circle, so it's not in the center like the central angle. Its vertex is on the circle, and the two sides are going to be chords. Okay, an intercepted arc is the arc that lies between the endpoints of the inscribed angle. The degree of the inscribed angle is equal to, is equal to half the measure of the intercepted arc. So the measure of angle ABC equals half of arc AC. Okay, so the arc, when I say intercepted arc, it's the arc that the beginning and the end of the arc match up with the sides of that angle. Okay, so if it's half the arc, so if this arc was 180 degrees, then that inscribed angle would be 50 degrees. Okay, so those are inscribed angles. All right, let's do a few practice problems. But actually, there's one more thing. I got to talk about overlapping arcs. If two inscribed angles intercept the same arc, then the angles are congruent to each other. If two inscribed angles intercept the same arc, then they're congruent to each other. So let's look at that. So I'll do one in green. So angle ABD, ABD. See how the beginning and the end of the arc, it matches up. The beginning and the end of arc AD match up with angle ABD. All right, so like the sides of the angle are forming that arc. Well, there's another angle that has that same arc, angle ACD. See how the beginning and the end of arc AD also match up with angle ACD. So basically, if they have the same intercepted arc, then those two angles are going to be congruent to each other. So angle ACD. Because think about it, if I told you this arc was 80 degrees, the rule is both those angles, the blue angle and the green angle, are both inscribed angles. They would both be half of that arc. All right, let's try some quick problems here. So I want to find the first one. I want to find the measure of arc DGF. So that's this right here. Well, I'm going to highlight the angle. The angle DEF is an inscribed angle. If the angle is 113 degrees, the angle is half the arc, so the arc has to be twice that. So it's going to be 226. All I did was 2 times 113. The angle is half the arc, so the arc is twice the angle. Angle PQR. All right, so I'm going to highlight that again. PQR in yellow. Well, it matches up with this arc, and that arc is half of a circle. So the arc is 180 degrees. That makes that angle 90 degrees. Okay, and then this one right here is angle, let me get the yellow. Angle ABC is 47 degrees. So this arc right here has to be twice that. Remember, the angle is twice the arc, or the arc is half the, the angle is half the arc is twice the angle. So this right here would be 94. But I really want to find arc BC. So arc BC is going to be this arc right there. Okay, it's just going to be 180 minus 94, which is 86 degrees. And the very last thing that I have to do is to talk about inscribed quadrilaterals. So an inscribed quadrilateral it's a quadrilateral that's inscribed in a circle. Its opposite angles are supplementary. Now hopefully you guys remember that supplementary means that they add up to 180 degrees. So the opposite angles, like angle A and angle B, angle A and angle C have to add up to 180 degrees. All right, I'll mark those in purple right here. They're not equal to each other, but see how they're opposite each other? So those equal 180 degrees. And angle B and angle D also have to equal 180 degrees. These guys right here equal 180 degrees. All four angles have to add up to 360, but the opposite angles, only if it's inscribed in a quadrilateral, only if the quadrilateral is inscribed in a circle will that be true. So let's look at this. Angle W. Angle W is 5x plus 1. Okay, 5x plus 1. And angle Y, which I have right here, angle Y is 13x minus 37. See how those are opposite angles that are part of a quadrilateral that's inscribed in a circle, so they have to be equal to 180. So all I'm going to do is to write an equation, 5x plus 1 plus 13x minus 37 equals 180. So that's 18x minus 36 equals 180. 18x equals, I'm going to add 36 and I'm going to get 216. And then I'm going to divide by 18 and I'm going to get x equals 12. Now be careful though, because I'm actually asking you to find angle Y. So angle Y is just equal to 13 times 12 minus 37, and that equals 119. Okay, and that's it for today. We'll practice all that tomorrow.